Hello students, I hope you are doing well. So today we are going to discuss the questions in center of mass, collisions, right? Momentum. Let's start with this question. A simple pendulum of length 1 meter has a wooden bomb of mass 1 kg. It is struck by a bullet of mass 10 power minus 2 kg moving with a speed of this 200 meters per second, right? The bullet gets embedded into the bomb. The height to which the bomb rises before swinging back is. So suppose that this is a wooden pendulum, that this you may consider like a block, some kind of block it is. It's like a wooden, made up of wood. So here there is a bullet going to come. So suppose this is a bullet. So this bullet is moving with 200 meter per second. 200 meter per second, and its mass is 0.01 kg. Right? This mass is 1 kg. This wooden bomb, its mass is 1 kg. So what will happen just after collision? You can assume that collision happens, and just after collision what happens, and it is given that bullets gets embedded into the bomb. That means together the total mass, how much will be the total mass? Total mass will be 1 plus 0.01. So that becomes how much? 1.01 kg, right? And just after collision, it is started moving with some velocity. Let us say the velocity is v. Okay, and that velocity we have to count, and based on that you can consider that it will go in a circular motion, right? And maximum height they are asking, so suppose it goes to some maximum height. After that it stops, right? So here finally velocity will become 0. So this height up to which it goes, that height we can calculate. This is the height they are asking in the question. So we can apply energy conservation. So total mass is m. Let us say total mass is m. So initially the kinetic energy of mv square is equal to potential energy mgh. So from here directly you can understand that this h must nothing be, it is just mass get cancelled. It is v square by 2g. This velocity we have to calculate first of all using momentum conservation. So what will be the velocity? Let's apply momentum conservation initially. So initial momentum and final momentum just after collision. Okay, just before and just after only, because after this point onwards it is going up. That time there are other forces acting. So during collision and when it is happening, the only force is impulsive force we have to take, right? So let's apply here. Initial bullet has mass 0.01 and velocity 200, right? And this was at rest. Finally the total mass 1.01 is moving with velocity v. So from here we got the velocity v. So how much? This is becoming 2 divided by 1.01, right? Meter per second. This velocity we need to substitute it here and calculate. So let's substitute here, calculate. So you may write it also 200 by 101, isn't it? You can also write this as 200 by 101 meter per second. This calculation we have to do. So 200 by 101 whole square divided by 2g, and what is the value of g we should take? So g we can take as 10, right? So how much this is going to come? From here this height h can be calculated, right? So how much it will come? So 2 square, let's say 4, and this is 10 to the power 4, and this is 101 square into 20, right? So approximately how much this height will come? Some approximations are involved, I think, here. So if you calculate, so 2 and this 10 will get cancelled. So 2000 by 101 square. Now approximately how much this will be? Suppose this is 100 square, that means it will come 10 power 4, right? So 3 will get 0.2, nearly 0.2 will come, but it will be something near to that, okay, 0.2. So because denominator is little large, so it is going to give us a different answer. It should be less than point, right? It should be less than 0.2. So little bit less, or approximately, I think approximately if you use, we can get that, right? Suppose if you use approximation, then this is 2000 and here 101. If I take 100 near about, so this will be 100, right? So we can cancel this 1000. So approximately we can say 0.2, right? So approximately we can use this 0.2 meter. Our calculations are in meter, so 0.2 meter, 0.2, right? Option 2, right? Then let's go to the next. Next question. The identical spheres, each of mass 2 capital M, are placed at the corners of a right angle triangle with mutually perpendicular sides. Okay, so let us say that there are triangle and this is a right triangle. This angle is 90 degree and spheres are kept of mass 2m at the corners. Corners means we can keep here and one here and one here, right? These are the 3 spheres, you can say. We have this one sphere and this is another sphere kept here. Identical means they are exactly similar, mass, size, everything same. Okay, so these spheres are kept here and it have mass 2m, 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 right? And sides are 4 meters. They have given these sides 4 meter. These sides are 4 meter. This hypotenuse is of course different. Taking point of intersection of these two sides origin. So let's take this as origin 0, 0, right? The magnitude of position vector of the center of mass of the system is the center of mass where it is, that we have to calculate. Okay, so first coordinate, if I take x and y coordinate, you can calculate. So x1 is 0 origin, y1 is also 0, x2 is here 4, and what is y2? Y2 is 0, this coordinate, right? Similarly here if I write this x3 is 0 and y3 is 4. Now let's calculate x coordinate of center of mass. So x coordinate of center of mass is m1 x1, right? So first mass is 2m into center of mass x is 0. Next 2m into x2 4 plus 2m into 0 divided by total mass, sum of masses 2m, 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 6m, right? So x center of mass we are getting from here is you can see it is 4 by 3, because mm will get cancelled and 4 by 3 will get. Similarly y center of mass we calculate. Y center of mass is how much? Same manner, 2m into 0 and 1 y1 plus m2 y2, 2m into y coordinate is 0 plus m3 y3, 2m into 4 divided by total mass 6m. Here also you are going to get same as 4 by 3. Now the distance of the center of mass from origin, so I think this is the point which is coming as 4 by 3, 4 by 3, right? 4 by 3, 4 by 3. This is what is center of mass. Now this center of mass distance from origin, this we can calculate, right? This distance. So our center of mass will be root under x center of mass square plus y center of mass square. So both are same, so root 2 times it will become 4 by 3, correct? So finally 4 root 2 upon 3. So the denominator they are asking here, the denominator x must be 3, right? This is what it is, x must be 3. So this is 3 is the correct answer. Okay, integer type question. Then let us move to the next. Next, a uniform rod AB of mass 2 kg and length 30 cm rest on a smooth horizontal surface. So suppose for example that there is a rod. Okay, this is a rod on a smooth horizontal surface. This is kept. This is a rod which is kept on a smooth horizontal surface. Okay, like this. Now here they have given that mass is given, total mass is 2 kg and its length L is 30 centimeter, which can be written as 0.3 meter. Impulse of force 0.2 Newton second is applied to the end B. So this is rod A and B you can take. So at this end there is a impulse acting. Impulse. What is impulse? Impulse is basically force into time. So this they have given 0.2 Newton second, right? This is acting. Okay. The time taken by the rod to turn through right angles will be. So this is the center of mass. So about center of mass, let's consider rotation. Rotational effect will be there. So of course center of mass also is going to move. There will be free center of mass as well. But we are going to only consider the rotation because they are asking time to rotate at right angles, rotate through right angles. Okay. So omega we need to calculate. So let's consider the torque or angular impulse. Angular impulse. What is angular impulse? Angular impulse is I into omega. So about center of mass we consider I center of mass into omega. So angular impulse will be force. Basically it is torque into time, right? The torque here is force into this distance L by 2 because this is the perpendicular distance, right? So we need to consider force into L by 2, that is what is torque, into the time t, and this I center of mass into omega. So from here you can understand they have given here force into t, which is 0.2. Force into t you can club together, and this is length by 2, and I center of mass is what? I center of mass is ml square by 12 into omega. So from here let's cancel out, one length get cancelled, okay, and this 2 also will get cancelled with 6. So from here omega we can calculate. Omega is going to be 6 into 0.2, that means 1.2, right, divided by mass into length, right. Let's substitute 1.2, mass is 2 and length is 0.3. So let's calculate first omega. How much this omega will come? So 1.2 by 0.6, I think this is going to give us 2, right, radian per second. So once we have calculated this, now we have to calculate the time taken to rotate by some angle which is 90 degree. So pi by 2, right, pi by 2. So rotation should happen for 90 degrees. 90 degree means pi. So you know omega is equal to theta by t. So therefore time is equal to theta by omega. Now just substitute time, calculate theta is pi by 2 by omega is 2. So we are going to get pi by 4 second. Pi by 4 second will be the answer for this. Okay. Now let's check what they are saying. They are saying pi by x. So x must be 4. X must be 4. So we can say here that the answer must be 4. Okay. Then let's move to the next. A spherical body of mass 100 gram is dropped from a height of 10 meter above the ground. After hitting the ground, the body rebounds to a height of. So suppose that there is an object, right? Let us consider that this is an object. Its mass is given. The mass is given as 100 gram. 100 gram. And this is falling to ground, right? This is ground. Let us consider this is the ground. And to this ground it is falling from the height. Height is given how much? 10 meter. 10 meter. So after it falls, after hitting the ground, the body rebounds to a height of. So first of all, this falls from this height and it's going to hit it. After hitting it, it again bounces back, and this time it is going to exactly half of the height. So this time after bouncing, so it is going up to this height. This height now is you can take as h dash. Okay, h dash is 5 meters. They have given this. The impulse force imparted by the ground to the body is given by. We have to calculate the impulse force. Okay, or you can say it's not exactly force, it is impulse. Basically impulse of the force imparted. Impulse of the force means it is the impulse basically. So we need to calculate impulse. Impulse is nothing but change of momentum, delta p, right? Delta p only we have to calculate. So if you know that what will be the velocity with which it is going to hit, let us say it's u, and just after hitting, it is bouncing with a velocity v. If you know that velocity, then change of momentum you can calculate, and the signs are also important. So this u, if you consider downward direction as negative, so u will be negative and v is going to be positive, right? So first of all, let's calculate u. So u is going to be root under 2gh, and it is going to be negative, so you can put its value as minus, right? And v is going to be positive, root under 2g h dash, right? Once you get this, then you can calculate change in momentum, right? Change in momentum is mass into final velocity, right? And minus mass into initial velocity. So when you take mass common, this v minus u comes out, right? And here you can clearly see that minus of minus u will get added together. So mass, and it is root under 2g h dash, and plus, right? Plus root under 2g h. This is what calculation we have to do. Just we have to do this calculation. Mass is 100 gram, means it is 0.1 kg, right? And root under 2g, so g is 9.8, right? So 2 times of g you have to calculate, right? So how much it is going to do the calculation. Just root under 2 into 9.8, right, into height. So initially this height is, let's say, 5, and root under 2 into 9.8, and this height is 10. So how much the calculation will give us? Very simple calculation it is. Maybe you will get easy calculation. So 0.1 into, so here you can say that it is going to be 9.8 into 10, so that is going to be 98, right? And here also you are going to get 98 into, that means 196, right? Let's calculate this, how much it will be. 0.1, and of course 98 means 49 into 2, so 7 root 2 will come, correct? And this is of course going to be how much? 14, right? This is going to be 14, because 14 is square 196, right? So how much now we are going to get? 0.1. And now check the options. Options are near to what? Near to what we can try to just calculate. So if you take 7 outside, so how much you'll get? You'll get root 2 plus 2, right? So 0.1 into 7 into root 2 is 1.4, near to that. So 2 plus 1.4, so this will be near to 3.4, isn't it? So 7 into 321 point something, it should be larger than 21, but here 0.1 is also there, so there is one extra factor near to 2 point something, it should be there, right? So you can go without full calculation. 2.39 can be chosen as the answer, isn't it? No? If you want, you can do the full calculation. You can remove this and let's say this is 100 will come, and multiply 7 into 4, 28, 2, and 7 into 3, 21 plus 2, 23, right? And divided by 100, so near to 2.38, right? So 2.38 or 39, near to that we can choose this answer, right? Let's go to the next question. If the total energy transferred to a surface in time t is this much joule, then the magnitude of the total momentum delivered to the surface for complete absorption. I think this question is talking about photons basically, or light radiations which are falling. So suppose there are some photons. Photons means particles of light, and these photons are falling on the surface, and these photons after hitting it, gets absorbed. So that means if you read the question here, complete absorption means this does not bound up, right? So let's say it is coming with a momentum p, and that's the initial momentum, you can say, and finally the momentum becomes 0 because it gets completely absorbed. In case of reflection, we have to consider it's bouncing backward, right? But here final momentum of the photon, this is photon, that is 0. Okay, and of course light travels with a speed c, that we already know. Here it is saying that the energy with which it is traveling is E. E is the energy which is given, right? Total energy transferred to the surface in time t is that energy they have given, that energy which is transferred, that energy represents the kinetic energy of the photons, right? Now the question is, what is the momentum delivered to the surface? That means what is this momentum which is delivered? Okay, so how do you calculate this? First of all, we should understand that these photons are going to hit normally. Of course it is hitting at an angle of 90 degrees, that we have to assume it. Okay, and now let's say that the total change of momentum here, delta p, magnitude wise I am writing this momentum is p because final momentum is 0, right? So the force that it will be imparting is change of momentum by time interval, and let's say momentum is change is p and time interval is t. Okay, this is the force, right? Now with this force it can have some pressure it can create, right? But what we want to calculate is change of momentum p only we want to calculate. Okay, so let's see p, how do we write here? P will be F into T. Okay, now what we can do, we can write this force, we can multiply distance x, or what you can do, let's say it is traveling with a speed of it is traveling, the photon is traveling with a speed c, so this c is equal to x by t, distance by time. From here time can be written as distance by speed, so this time can be written as distance by speed, but force into distance, that will become energy or work. So this formula which we are getting here is momentum is equal to E upon c. This calculation only we have to do. If you remember this formula, then directly you have to do division, right? So energy they have given 6.48 into 10 power 5. So let's do the calculation. 6.48 into 10 power 5 by speed of light 3 into 10 to the power 8. That we should know. Okay, so from here you will get approximately 2.1 and 368, right, into 10 power minus 3, isn't it? In SI unit, 2.16 10 power minus 3. That's the correct answer, option 2. Then let's move to the next question. Next question says that a solid circular disc of mass is given, okay, rolling along a horizontal floor so that its center of mass has a speed. It's rolling. Absolute value of work done on the disc to stop it is. So suppose this is a disc, okay, rough diagram, and this is the ground of the surface, this is the ground, and this is rolling. So it is going like this, and the center of mass is moving, v center of mass, and this is the angular velocity omega. So of course we can consider pure rolling. When they did not mention anything, we have to understand that this is just pure rolling only. Okay, then only we can do the calculation. So if you consider that this gets stopped, so initially it has some energies. What are the energy, kinetic energy initially? One is half m v center of mass square plus half I omega square. This is the energy which is going. Okay, even if you may not consider pure rolling, but then in that case they should give what is V and what is omega, then you can calculate. But here they have only given the center of mass velocity, and in pure rolling V center of mass is omega into r for pure rolling. So that's why this formula we have to use, V equal to omega into r. So let's convert it half, because this they have given V, that is 0.4 meter per second. Okay, so kinetic energy when we are calculating it, half, right, half mass V center of mass square, plus it is a disk, right, solid disk, so moment of inertia about center of mass is half mr square by 2, right? So mr square by 2, and omega is V by r, so V square, V center of mass square by r square. So from here r square terms get cancelled, and you see this is half V square center of mass plus m V center of mass square by 4. So basically this is going to be 3 by 4 m V square center of mass. That's the total kinetic energy. And if it is going to stop, then we can say that work done by net force is equal to change of kinetic energy, right? Work energy theorem. So final kinetic energy 0, initial kinetic energy is 3 by 4 mv square. If you want, you can calculate this kinetic energy here itself. Calculate this. Okay, here you can do calculation. 3 by 4 mass is given. How much mass is there? This is 50 kg, right? 50 kg. And this V is 0.4 square you have to take. So how much it comes out? You can do very easily calculations, right? So 0.4, if you square 200 will come, 50 by 2 will come, right? And so 3 by 4, if you want, let us write. So 4 into 4 by 100 will come, right? So 50 2 times you can cancel, and this is 4 into 2 8, and here 16 by 2, so it will come 6 joule. So now while you are calculating here, minus 6 will come, isn't it? So minus 6 joule is work done by external force, but we have to calculate the absolute value. If you read the question, they are asking absolute value. So that means magnitude, you take magnitude of minus 6 magnitude, that will be 6 joule. The correct answer is going to be 6, just 6 here. Okay, this is how we can calculate. Okay, so this is what the type of question I have come this year. Okay, then we'll be seeing in the next class. Thank you for your attention.